Hi, my name is Ryan Holcomb, and this is my MAE535 project. I've made a desktop DC motor. This is the setup for it. It is a winding made of 28 gauge wire. In the top left, there's a around 5 millitesla permanent magnet. There's a 9-volt power supply in the bottom right made of 6 AA batteries, and all that's brought together in this breadboard on the bottom left with those battery leads connected to that winding in this setup. So this is the cross section of that setup. You can see this is the windings, and the current is going into the page on the bottom and out of the page on the top. And so with this magnet causing this magnetic field, obviously abbreviated magnetic fields, it's going up, and the current is going into the page on this bottom one. So this force is to the right. For the top, it's the opposite, and thus a torque is induced on this winding, and it drives the DC motor. So there are no commutator rings in this setup. So the way to get around that is to power it half the time, and for the other half, you just turn it off. Basically, you don't have this Lorentz force, so you let the inertia carry it on the second half of the rotation. So you are powered for the downswing, and then for the upswing you just let inertia take it. And you can kind of see these two steps right here. The way you do that is by exposing only part of the legs of this winding to the battery leads, so that when this part is touching, that's the time when it's not energized, and then on the top it would be energized because it's touching both leads. I've made 3 different windings for this DC motor setup. This one is 1 single wrap, this one is 10, and this one is 40. So I should expect to see a higher force with 40 wraps than I would with 1. And we can look at the quality of these motors in our next slide right here. I'm going to start with the 10 ring one. I made them such that they in order 40, 10, and 1, but I think this one is the smoothest one. It looks to be the fastest one as well. It is a good mix of force and weight. So I took away the magnet right there, and I'm going to start it again. I'm going to give it a little bit of inertia, a little bit of movement, so that way it can get the cycle going again. And obviously when I take away the magnet, it stops. So I'll move to the 1 wrap winding. I'm going to give it another push, and it starts spinning again. It does not look like it spins as fast as the 10 wrap one, but I think that's because there is less force, because it's less wraps. And it still is moving pretty good, so I was surprised about how good this 1 wrap was moving. But now we're going to move on to the 40 wrap, and it's a little bit different. I really like this because there's a lot of force here, but it's probably not the best for this setup. It's a little jumping, it's a little bit jumpy, it's jumping all around, and so might be missing the contacts sometimes where it stops and slows down. I think it's about to do that right here. Yep. So then if you can, yeah, look, so there it self starts again, which is pretty cool. It looked like it wasn't going to keep going, but it actually had enough force to get itself over and get itself started. I just think for this specific DC motor setup, the 10 wraps work a little bit better, smoother than the 40 wraps. And that would conclude my demonstration of this DC motor.